So what is viscosity? So viscosity is defined as the internal resistance of a fluid. It is a common knowledge that different fluids flow differently. This is due to the viscosity of different fluids. You can see in the figure how a honey flows and how water flows. Water almost flows without any resistance, but in honey it flows with some kind of a resistance. So what is a difference between a solid and a liquid? We have discussed it earlier, but let us discuss it again. So you can see in solid, when a force is applied, a shear stress develops and it stops deforming after a limit. In liquid, when a force is applied, when a tangential force is applied, it will deform continuously without any resistance. That is the definition of a fluid. So you can see here tan beta can be approximated as beta since the angle is very low, and tan beta is equal to delta x by delta y. So tan beta is equal to delta x by delta y, and when the limits are taken, beta can be taken as dx by dy. So in fluids, we are not taking shear strain, we are taking shear strain rate, that is beta dot, shear strain rate. So that is equal to d by dt of dx by dy. So that is equal to du by dy. So that is very important. In solid, we take beta, that is shear strain, and in liquid, we take beta dot, that is equal to du by dy. So what is Newton's law of viscosity? So we have seen in liquids, when a tangential force is applied, it will deform continuously. So a shear stress is developed at the top and an equal and opposite shear stress is developed at the bottom to counter the shear stress at the top. So the shear stress is equal to force divided by area, that is tangential force divided by the surface area. And the shear stress we have seen in liquids, shear stress is directly proportional to shear strain rate. So that is how Newtonian fluids are discussed. Newton's law of viscosity states that shear stress developed is directly proportional to shear strain rate, that is beta dot. So those fluids which obey Newton's law of viscosity are called Newtonian fluids. That means in those liquids where shear stress is directly proportional to shear strain rate, they are called Newtonian fluids. So that means tau is equal to du by dy. We have seen that beta dot or shear strain rate is equal to du by dy. It is the velocity gradient. U is the velocity gradient. So tau is equal to mu into du by dy, and this mu is called viscosity. The constant of proportionality is called coefficient of viscosity or dynamic viscosity. We call mu as dynamic viscosity. This is called dynamic viscosity. So what is the unit of viscosity? So you know that tau is equal to mu into du by dy. So mu is equal to tau divided by du by dy. So let us take the dimensions here. So the dimension of shear stress is dimension of stress, that is Newton by meter square, and the dimension of du, that is velocity, is meter per second, and dy, the dimension is meter, so that is Newton second by meter square. So the unit of viscosity in SI unit is Newton second by meter square. So what is this unit in CGS unit? The unit is poise in CGS unit, and 1 Newton second by meter square is equal to 10 poise. So what is kinematic viscosity? Kinematic viscosity is defined as dynamic viscosity by density. That is, nu is equal to mu by rho. So what is the unit of kinematic viscosity? Kinematic viscosity, so we have seen that the unit of mu is Newton second by meter square, and rho, you know, density, that is mass by volume, that is kilogram by meter cube. So that is equal to Newton meter second by kilogram. So the Newton, if you write the units, you can get it as kilogram meter by second square, because Newton, that is force, is equal to mass into acceleration. The unit of mass is kilogram, unit of acceleration is meter per second square. So if you simplify it, you will get meter square by second. So unit of kinematic viscosity is meter square by second, and the unit is meter square by second in SI unit, and in CGS unit the unit is Stoke, and 1 Stoke is equal to 10 raised to minus 4 meter square by second. So what is the effect of temperature on the viscosity of a liquid? You can see here the viscosity in liquid is due to the intermolecular forces. So as the temperature increases, the intermolecular forces will get reduced. So that means the viscosity will also get reduced in case of liquid, because viscosity is due to the intermolecular forces. So as intermolecular forces are reduced, viscosity will also get reduced. So what is the effect of temperature on the viscosity of gas? So unlike liquids, the viscosity of gas is due to intermolecular collisions. So here the intermolecular forces are comparatively very weak, and viscosity is due to the intermolecular collisions. So as the temperature increases, the intermolecular collisions will increase. So the viscosity is due to the intermolecular collisions. So the viscosity will increase.